this experiment, we will be observing how substances with different intermolecular forces boil at different temperatures. As you've probably already learned, intermolecular forces are the forces within a molecule, the forces that keep the molecule together, while intermolecular forces are forces connecting different molecules and are responsible for keeping a substance in a solid or liquid phase, which means the intermolecular forces are the forces that have to be broken in order for a substance to vaporize. In this experiment, we will be focusing on the intermolecular forces since those are the forces that must be broken in order for a substance to boil. There are 4 types of intermolecular forces, the first one being ion-dipole, in which the polar molecule is bonded to an ion. The next is the hydrogen bond, in which a hydrogen atom is bonded to electronegative atoms such as fluorine, oxygen, or nitrogen. Dipole-dipole forces are forces in which the positive end of a polar molecule is attracted to the negative end of a polar molecule. And lastly are London dispersion forces, the weakest of the intermolecular forces, and occur between 2 nonpolar molecules. The intermolecular force between 2 water molecules is called the hydrogen bond, one of the strongest of the intermolecular forces. Ethanol experiences 3 intermolecular forces: hydrogen bonding, dipole-dipole bonding, and London dispersion forces. Even though both substances have hydrogen bonds, the molecular weight of ethanol is much larger than the molecular weight of water, therefore making the hydrogen bonds between ethanol molecules less strong than the hydrogen bonding of the water molecules. This is why we observed ethanol boiling at a temperature of about 70 degrees Celsius and water boiling at a temperature of 100 degrees Celsius.
Fractional distillation is a method of separation using boiling points. The substance that has the lower boiling point will be able to boil off and be collected, separate from the substance with the higher boiling point. Today we will be using a mixture of water with a boiling point of 100 degrees Celsius and ethanol, which has a boiling point of about 78 degrees Celsius. Now the fractional distillation apparatus is composed of several parts: the variac, heating mantle, round bottom flask, distillation column, stillhead and thermometer, condenser, bent vacuum adapter, and 10 milliliter graduated cylinder. The first piece is the variac, which basically acts as a power source for the heating mantle, which is the source of heat. The mixture of your liquids, in this case a mixture of 20 milliliters of ethanol to 30 milliliters of water, is going to be placed in a round bottom flask, and this is where all of the boiling takes place. We've added some boiling chips to speed up the process. Once one of the liquids begins to vaporize, it's going to move up through the distillation column, which is essentially a long glass tube with a bunch of pegs inside. The vapor will actually condense one time within this tube before evaporating again and moving through the rest of the system, so the pegs collect the excess vapor and make sure that all of the liquid ends up back in the round bottom flask. The next piece is the stillhead, and it basically acts as a connecting piece and holds your thermometer in place. Now the thermometer is really important to pay attention to. If you know the boiling points of your liquids, this can be a good indicator of what is boiling off. In theory, once the mixture starts boiling, the temperature should remain constant at the boiling point of your liquid with the lowest boiling point. Once you see a large jump in your temperature, you need to turn off the heating apparatus because you've started vaporizing your liquid with the higher boiling point. In the case of water and ethanol, you see a large jump from about 78 degrees Celsius to 100 degrees Celsius, but some liquids have closer boiling points, so it's incredibly important to pay attention to your temperature. Once your liquid has vaporized and moved through the distillation column, it's going to pass through the condenser. The condenser is a long glass tube insulated by another glass tube. The reason for this is that cool water will be passing through the 2 walls of glass, while your vapor moves through the middle. This will cause the vaporized liquid to recondense so that it can be collected in your graduated cylinder. The final 2 pieces are the bent vacuum adapter and a 10 milliliter graduated cylinder. The vacuum adapter is really just another connecting piece, and the 10 milliliter graduated cylinder is there to collect the separated liquid. For this experiment, we only collected up to 20 milliliters of liquid because we were aware of our initial concentration of ethanol. However, fractional distillation can be used to determine the concentration of an unknown mixture. Just to double check and make sure that our experiment worked, we performed 2 tests. We first smelled for ethanol by wafting the scent towards us, and it became immediately evident that ethanol was the liquid present. Our second test was adding water to the beaker containing our liquid. This resulted in wisps appearing as the two liquids mixed, which is indicative of an alcohol being present.